This is Algebra 2, Lesson 1.3 Homework Solutions. Let's dive in. I will note that in each of these problems, I am looking at the answer key at the end of the problem to check my work, so I'm just using that on a second monitor to go faster. In problem number 1, let's read. Javier opened a new apparel store. For the first year of business, Javier sets sales goals for each week, which will allow his business to grow sustainably. The first 4 weeks' weekly goals are shown in the table above or below. The pattern continues for the first year. So for the first week, that goal, second week, that goal. It looks like he's increasing his goal every single week. What is Javier's sales goal for the last week of the year? And their 1 year has 52 weeks, so the 52nd week will be the last week. So essentially what we're doing here is we're doing ... and we're asking for 52, and what is that amount? Well, what are we increasing by each time? So to find the common difference, you just subtract any term that you want. If I go 1,805 minus 1,425, that's a little bit hard for me to do in my head, but doing 2,185 minus 1,805, that is a little bit easier. I'm gonna do that one first. So to get from here to here, 85 minus 5 is 80, 21 minus 18 is 3, so 380. So I think I'm doing plus 380 each time. Just to check that with a calculator, we do have access to calculators. If I come over here to my scientific calculator, I should now be able to verify. If I do 1425 plus 380, I get 1805. If I add another 380, I turn it into 2185. If I add another 380, I turn that into 2565. That seems to be working. So I'm constantly adding 380 each time. I can annotate that in here. Plus 380, plus 380. And for the last week, we're not adding any of these, but we're not doing 1425 plus 1805. We're not figuring out how much you add up for the year. We're just trying to figure out the last box, which means we need to find the pattern. Well, the general rule for our pattern is you can make a function. That's how I'm going to choose to interpret this. I'm going to say S is the sales goal, and if we input the week, so W for week. And the way that we do this is, let's just choose randomly the first one. So I'm going to do 1425, and then we're going to do W minus which week did we do? 1. I could have done this equation, or I could have done another one. I could have done like the sales given the week is equal to, let me randomly choose a third one. I could have said 2,185 times W minus, okay, which term did I choose? I chose the third term, so I'm going to put this 3 over here and say this is the third term. All of these will work. None of these will work because I made a mistake. Silly Mr. Sindel. This is the starting number, but then we need to add the common difference times this term. I super apologize. I don't know what I was thinking there. So what I need to do is move these over, move all of those over, and move you over. What I really need to do here is say that we're adding 380 times that number plus 380 times that number. Now both of these are valid equations. Okay, so let's go ahead and type this into our calculator. So if I come back to our calculator, let's go here. I'm going to enter my first equation. So I'm going to say 1425 plus 380 times the quantity of, I don't have, well, I guess I have a W minus 1. And if I enter a value for W, like W equals 1, I should spit out 1425. It does. If I type in W is equal to 2, it does a second week. If I do 3, it does a third week. It seems to be working. So I need to do week 52. And when I do 52, I get 20,805. So $20,805 is my final amount. The way that I did that is I did S of 52. And that's going to be 1425 plus 380 times 52 minus 1. 52 minus 1 was 51. 51 times 380 is a number, and then you add that to 1425 to get our final answer. Excellent. All right, number 2. The recursive formula describes an arithmetic sequence. Okay, so we start with the first term, and to get the next term, we take the previous term, and then we add 7. So you're constantly adding 7, adding 7. So if I write this term out, I have the first term is 12, then I add 7, I get 19, and then I add 7, I get 26, then I add 7, I get 33, and then so far and so more. So far, what is that? I don't know. My brain's not working right now. So we need an explicit formula for the sequence. So here is the way that we do an explicit formula. It's the same thing that we did in example 1. Let me write it out. We'll say that a sub n is equal to our any term. We can say a sub 2 if you want. or let's do a sub 7. You can randomly choose a number, and then you're just going to add the common difference times n minus whatever number we chose. If this number is 7, this number is 7. This is the 7th term, therefore you subtract 7. Or you could do the first term and subtract 1. It doesn't really matter. So I'm going to come down here and say our formula is a sub n is equal to, I'm going to choose the first term because I'm being lazy. I'm going to say 12 plus, okay, the common difference, we're constantly adding what number? Adding not what number? We're adding 7 each time. So it's going to be 7 times n minus 7. And that is the exact, or n minus 1. I don't know why I said 7. That's the first term. And I'm checking the answer key. That is correct. Good job, Mr. Sandell. And it says find a of 15, find the 15th term. So the 15th term, we just plug in 15 to this n and we're done. So we'll say a of 15 is going to be equal to 12 plus 7 times 15 minus 1. And I could do this without a calculator, but in the interest of going fast, I would like to use a calculator. So let's come over here and say I'm going to do 12 plus 7 times 14 times 14. I did 15 minus 1 in my head, so that's 110. So it's going to be equal to 110. A sub 15 is equal to 110. The 15th term is 110. Find the sum of the first 15 terms in the sequence. Oh, that's a little bit trickier. So the way that we do that is the general formula is going to be we do the number of terms, n, divide by 2 to get the number of pairs, and we're going to multiply that by the first and the last number. So we'll say a of 1 plus a sub n, because these are the rainbows. So it's rainbows times number of pairs, essentially, is what we're doing. So what do we have here? How many terms do we have? This is the number of terms. We have 15. So I'm going to say this is going to be equal to 15 over 2. And this is going to be multiplied by, okay, what is the first term in the sequence? Well, the first term in the sequence is, we already have it up here. The first term is 12. So I'll say 12 plus the last term in the sequence. Well, the last term in the sequence is going to be the 15th term. And hey, the 15th term, we just did it up here, is 110. So I'll say 110. And then we can just solve this by plugging into the calculator. What do we got here? This is going to be 15 over 2, and this is going to be times 12 plus 110, and you get 915. It's going to be equal to 915. So they all add up to 915. Nice. All right. Number 3. Find the sum of the first 13 terms of this sequence. Okay, so what number 2 did is it gave you a building block. It said, okay, what you're going to do is we have a sequence. What we're going to do is we're going to find the pattern, use the pattern to find the last number, and then once we have the last number, we can plug in the first number, the last number into these two spots. We already know how many terms there are, and then we can just plug it in. It's going to be the same process again in number 3, but it's not doing it A, B, and C. You're supposed to do it on your own. So I'm first going to make a rule. The rule states that I'm going to have, I can find any term by doing the following. I'm just going to randomly choose 52. I take 52, and then I'm going to add the common difference. In this case, I'm going to be subtracting, so I'm going to put a minus sign. How much are we subtracting each time? Get from 52 to 49, I did minus 3, minus 3, minus 3. They're always subtracting 3, so subtract 3. I'm going to move this down a little bit because it's getting cramped in here. And then you're going to multiply this by n minus, okay, well, which term did I choose here? I chose the first term. If the first term, I'm going to write it 1. If it was a second term, I would choose a 2. So it's the first term, I'll write it 1. So that's the pattern. And I want to find the last term, because essentially what I want to do at the very end of this, I want to plug into this formula. I want to plug into n divided by 2, the number of pairs, times the sum of the arcs. The arc is a1 plus a sub n. In this case, a sub n is 13 because it's the first 13 terms. So I'm going to come up here and change the n to a 13. I know what the first term is. The first term is 52. I know how many terms there are. There's 13. The only thing I don't have is the 13th term, which is why we have this formula. This formula will help us to find the 13th term. So let's do that now. The 13th term, a sub 13, is equal to 52 minus 3 times, not n, but 13 minus 1. And this I think I can do in my head. So this is going to be 52 minus 3 times 12. This is going to be 52 minus 36. Which is the same thing as doing, I'm going to add 4 to them, so 56 minus 40, that's going to be equal to 16. So the last term in the sequence is 16, and I'm ready to plug in. So I have a sub 13, I know that 52 is the first term, a sub 1, and I know that n is 13. So plug everything in. I have 13 over 2 times the first term, 52, plus the last term, 16, and I don't really want to do this without a calculator, so I'm going to go back to the calculator. What do we have here? Also, I just want to double check my math to make sure I'm correct. I don't want to make a mistake if I can avoid it. 52 minus 3 times 12. Okay, it was 16. I was just making sure. And then I'm going to do 13 over 2 times, in parentheses here, 52 plus 16, and I get 442. So this is going to be equal to 442. Final answer and box it. So essentially we did everything from number 2, but all in number 3, and we're knowing the process now over and over. Number 2 is giving the hint for number 3. Number 4, we're talking about Drew. Drew is going to try out for the basketball team, so he decides to shoot free throws every day at the park. Good job, Drew. On the first day, he shoots 15 free throws, I can say that. On the second day, he shoots 25 free throws. It's increasing by 10. 15 and 25 is 10. On the third day, he shoots 35. An additional 10 from 25. 10 more each day. Drew continues to increase the number of free throws he shoots each day by the same amount, which that same amount is 10, we already know. If Drew continues to follow this pattern, how many free throws will he shoot on the 20th day? So we're just trying to find this last number, the 20th day. To find that last number, we need to find the pattern and use an explicit sequence. So the explicit sequence is this. A sub n is equal to, I'm going to randomly choose the second term, just to show you I can use the second term. A sub 2 plus the common difference times n minus 2. If this was the first term, this would be a 1 here. So I'm going to say a sub n in this case is going to be equal to, okay, on the second day, he chose to shoot 25 free throws, plus the common difference, he's adding 10 more each day, and then n in this case is still n minus 2. Okay, so here's our equation. Now we want to figure out the 20th day, so I'm going to plug in 20. A sub 20 is going to be equal to 25 times, or 25, sorry, plus 10 times, and then the 20th day is going to be 20 minus 2, n is 20. And we can do this in our head, because, or do it on paper. 25 plus 10 times 18. This is going to be 25 plus 180, and this is going to be 205. 205. Checking our answer. We got it correct. All right, B. How many free throws will Drew have shot total during those 20 days? So this is the one where we're doing number of pairs, so n divided by 2, times the first term plus the last term. The last term now is not a sub n, but a sub 20. What do we know? We know that there's 20 terms, so it's going to be 20 over 2, times the first term. First term, on the first day, he shot 15 free throws, plus the last term, which we just figured out in the last problem, is 205, and we just need to do this on our calculator. This one I think we can do in our heads as well, because this comes out so nice. 15 plus 5 is 20, so this is 220, and then 20 divided by 2 is 10, so it's 220 with an additional 0 on there, 2,200 free throws. On to number 5. Sean, he joined a 10-day fitness challenge for his PE class. Good job, Sean. All these students are so healthy. Each day, Sean has to do 5 more push-ups than he did the day before. If Sean did 20 push-ups on the first day of the challenge, how many total push-ups will he have done during the 10-day challenge? Okay, so we know that the number of terms is n, and we know that 20 is a sub 1. We don't have a sub 10, otherwise we would be done. Because again, I'm plugging into the formula, n divided by 2 to figure out the number of pairs, times a sub 1 plus a sub 10. The first, I meant to write a sub 10 there. The first term plus the last term for the rainbows, and then number of pairs. So we need to figure out a sub 10. The way that we figure out a sub 10 is with the pattern. So I'm going to use a sub 10. We're going to figure out down here, to figure out the pattern, we're going to do a sub n, we're going to write an explicit sequence. Our explicit sequence will always be, okay, we're going to say the first term, so 20. The common difference, he's doing 5 more each day, so this 5 here is our D for common difference. 5 times, and then we're going to do n minus, which term did we do? The first term? Yes, so that's going to be 1 here. All right, and we're ready to plug in, right? So I can move a sub 10 back. I'm ready for you now. A sub 10 is going to be 20 plus 5 times 10 minus 1. This is going to be 5 times 9, which is 45. And this is going to be 65. So that means that the 10th term is going to be 65. So what we have now is we have the ability to plug all these in. We have a sub 10, which is going to be 65. We have a sub 1, which is 20. And we have n, which is 10. And then we divide that by 2. All right, let's see what we've got here. 65 plus 20 is 85. And then multiply by 10 to get 0, and then divide by 2, and this is going to be, let's see, 8 divided by 2 is 4, 50 divided by 2 is 25, so 425 push-ups. Wow, in 10 days, 425 push-ups. Good job, Sean. All right, number 6. We have this summation notation that I talked about at the very end of the lesson. So we want to write each expression as a sum of terms and calculate the sum. Okay, so we want to actually write out, what is this thing equal to? This is equal to 1 plus 2 plus 3. What is this thing equal to, right? And then once we find what it's equal to, then we'll actually calculate what that summation is. So the way that you do these problems is you plug in 1. Plug in 1 to k. And what do you get? Well, you'll get 130 minus 15 times 1, which is going to be 130 minus 15, which is going to be 115. So the first term of the sequence is 115. How do we do the second term of the sequence? The second term of the sequence is going to be, I'm rewriting this formula again, it's going to be 130 minus 15, but now we increase this number from 1 to 2. So I'm going to plug in a 2 here, because this value of k is the index, or it's the term number, right? So it's going to be 130 minus 30, and 130 minus 30 is 100. So that means that the first term is 115, the second term is 100. You can kind of see the pattern here. Let me do a third term just to make sure you've got it. The third term here is going to be 130 minus 15 times 3. That's going to be 130 minus 45, and that's going to be 85. So you can even see it in just these terms that you're going down by 15. Minus 15, minus 15. We're constantly subtracting 15. So the way that I would write this as a sum is I would, oh, and how many terms do we have? It says there are going to be 4 terms. So we might as well just do the fourth term right now. I'm going to use the pattern so I don't have to do any math. The fourth term here is going to be, I just subtract 15 again, so minus 15. If I subtract 15, that's going to be 70. So I'll just put 70 over here. So those are the terms, and I'll write this out more explicitly. I'll say that this is equal to 115 plus 100 plus 85 plus 70. Okay, so we've answered the first part of the question. That's the expression as a sum of terms, done. And now I'm going to calculate the sum. So I need to actually calculate what this is. And again, the way that I do this is I'm going to do that rainbow method where I'm going to do first plus last, and I'm going to multiply by the number of pairs. So in this case, I'm going to, I don't have enough room here. I'm going to move B and do it somewhere else. Actually, I'll continue A right here, and hopefully that's enough room for B. So what I'm going to do here is I'm going to say, I'm doing our formula, n divided by 2 to find the number of pairs. This is going to be multiplied by the first term plus the last term. The last term in this case is a sub 4, because our n up here, this is our n is equal to 4. And this is a sub 4. All right, so what do we have here? This is going to be the same thing as 4 over 2. There are a total of 2 of these rainbows, 2 rainbows. And then this is going to be first term, 115, plus the last term, 70. Okay, and we can do a bit of manipulation here. We can say that this is going to be equal to 2 instead of 4 over 2. This is going to be times 185. Okay, I just have to double 185. So if I double the 5, that turns into a 10. So I'll carry the 1. I'm holding the 1 on my finger right now for you guys. And if I double 18, I get 36, plus the 1 on my finger, which is 37. So this is going to be 370 for our final answer. And I'm checking my work up here, and it is indeed 370. So I'm going to go ahead and, do I have room up here? I'm just going to box 370. And I'm also going to box this. Those are the 2 parts of the question. All right, and I'm going to move A down a little bit so I have enough room for B. Okay, so this is all the room for B. I'm going to do B in black. Okay, so again, to find the first term, I'm going to just plug in this number into this formula. What do we get? We get 4 times 1 plus 5, that's going to be 9. Then I'm going to do the second term. The second term, I'm going to do 4 times 2 plus 5, and that's going to be 8 plus 5, which is 13. And you can already see the pattern. It's going to be going up by 4. And indeed, any number that's being multiplied here, watch this. We're going down by 15, we're going up by 4. The number that's being multiplied by our variable is the common difference. This common difference was a minus 15. This common difference is a plus 4. And I can just continue this pattern. I don't have to keep recalculating these terms manually. This is going to be plus 4 over and over and over again. 13 plus 4 is 17. And how many terms am I going to end at? That's the third term. I need to go fourth term, fifth term, sixth term, and not a seventh term. We end at the sixth term because it says end at the sixth term right there. So I'm just going to keep adding 4, 21, add 4, 25, add 4, 29. So here is one part of the question. It's asked to write this as a sequence of terms. Those are the terms that I'm adding up. And now I'm going to find what that is equal to. So again, I'm plugging this into the formula n over 2 times first term. I'll just say a sub 1 plus the last term, which in this case is going to be a sub 6. This is going to be 6 over 2 times the first term of 9 plus the sixth term, 29, And I can do this kind of quickly, I hope. This is going to be 3 times 9 plus 29 is 38. All right, here's how I'm doing 3 times 38 in my head. 3 times 8 is 24. I'm holding the 3 on my fingers for you guys for the 30 of the 4. Holding the 3, and then 3 times 3 is 9, plus the 3 on my fingers. 9 plus 3 is 12, so 124 for the sum. So checking my answers online, I got it wrong. All right, and that's because I didn't multiply correctly, I think. Yes, I didn't multiply correctly. Let me do that multiplication again. 3 times 8 is 24, 4, not 34. So I'm holding the 2 on my fingers. 3 times 3 is 9, plus the 2 on my fingers is 11. This should be 114. There we go. All right, that was number 6. Let's move on to number 7. Use the graph of the sequence to answer the parts. Write an explicit formula for the sequence. Okay, so again, you can choose any number of things. I'm just going to say a sub n in this case is going to be equal to, which one do you want to choose? I'm going to choose that one at random. That's going to be the third term. The third term looks to be 9. So I'll say 9 plus, okay, what's the common difference? This is going up by what, up by what, up by what? So this is going from 3 to 6, so that's plus 3, and from 6 to 9, that's plus 3, from 9 to 12, that's plus 3. It's a common difference of plus 3. And then we do n minus, okay, what term did I choose? Did I choose the first, second, and third? I chose 1, 2, 3. I chose a third, so I'm going to plug in a 3. A 3 here. That's an explicit formula. I mean, it doesn't match the answer key, but I know it's correct. All right, and then it says find a sub 40. So to find a sub 40, you plug into that formula. You're going to say 9 plus 3 times 40 minus 3. And I don't really feel like doing math right now. I got in a non-math mood, so I'm going to go ahead and use a calculator. What is this thing? It's going to be 9 plus 3 times 43. And you get 138. So this is going to be equal to 138. Checking my work, and I got this one incorrect. Why did I get this one incorrect? 138. It's saying that the answer is 120. All right, let's go ahead and check my calculations. I've made some silly mistake. Oh, why did I say 43? It's 40 minus 3, which is 37. There we go, 120. My mistake, guys. 120. That's why we always check our work. All right, and if I find the sum of the first 40, so S is the sum of the first 40, and that means we're doing n divided by 2 to find the number of pairs times the first term, a sub 1, plus the last term, a sub 40, and let's figure out what this is. This is going to be 40 over 2 times the first term, which is, okay, the first term in this case is 3, plus the last term, which we already know from the last problem, 40th term is 120, and just plug this into a calculator because we're getting lazy, but you can do this by hand. This is going to be 40 divided by 2 is 20. 20 times 123, that's going to be 2,460. 2460. 2460. Anytime we have a bunch of work, we should be boxing our work. Let me check these last 2 answers, and I got them correct. Answer key, got to scroll down a bit, and then I'm on to number 8. Samra has decided to make some flashcards to help her study for her Spanish exam. Man, all these prudent students, I love this. Each day she makes more flashcards to add to her collection. The number of new flashcards she makes on each of the first 4 days are shown on the table. She continues making new flashcards according to this pattern for 1 month. All right, so we need to find the 12th term and describe its meaning in the context of the problem. Okay, we've never been asked to do that, or maybe we haven't, I just haven't been paying attention. We need to find a pattern. We want to jump all the way here to the 12th number and find that missing number of new flashcards. So I'm going to do a sub n instead of a sub 12. It's going to be, I'm just going to randomly choose the first term, 5 plus, okay, what is the common difference? Each time we're going up by plus 2, plus 2, plus 2. We're constantly doing plus 2, so the common difference is plus 2. And then we're going to do n minus, okay, which term did I choose? Did I choose the first, second, third? I chose the first, so I'm going to choose a 1 here. All right, so I have my pattern, and I'm going to plug in the pattern. I'm going to say a sub 12. In this case, it's going to be 5 plus 2 times 12 minus 1. Okay, I can do this on paper. 12 minus 1 is 11. 11 times 2 is 22. 22 plus 5 is 27. So 27. Now we have to interpret that meaning in the context of the problem. So we'll say on the what day? This is the day. So on the 12th day, and then our name is Samra. Samra made how many new flashcards? 27 new, I'll just say cards. Done and done. All right. And then now we need to do S of 12 and describe its meaning and context. Okay, so I'm doing the sum of the first 12, which means I'm going to be doing number of pairs, n divided by 2, times first term plus the last term, in this case a sub 12. All right, plugging in, I have 12 terms, divided by 2, plus the first term is 5, plus the last term. Well, a sub 12, we found it right here, is 27, so I'm going to take 27 and plug it into a sub 12 right down here. So I'm going to say 27, and then just throw this into a calculator and do the math blender. Go, calculator, go. What have we got here? I'm going to do 12 divided by 2 is 6. 6 times 32, and I get 192. It's going to be equal to 192. Holy moly. Okay, and then again, it tells us describe its meaning in the context of the problem. So after 12 days, Samra has a total of 192 flashcards. Done and done. All right. Number 9 is blank, and that's all the problems. All right. So that concludes Algebra 2's lesson 1.3 homework. Thank you for watching.